everyone and welcome to a new discussion on this groundwater engineering course, and today topic which we are going to discuss in detail about surface water versus groundwater. Earlier also in beginning of this course I have very briefly introduced about this comparison, but now we will be seeing more detailed discussion on these two sources of water. Of course, the source of water is one, that rainwater or precipitation, but how they are either on surface or subsurface. So, what we see that surface water automatically it means that the water which is available on land in any form, basically, and that form may be river, ocean, lakes, seas or ponds. Local ponds are also very common, and these also serves very good groundwater recharge. So, whatever the water which is available on surface can be called as surface water, and whatever the water which is available below the ground surface in the earth, that is what is our groundwater. And as you know that it occupies all or part of the void spaces in soils or in geologic strata. Why I said the part? Because it is not necessary that the rocks are fully saturated with water or all voids or spaces, pore spaces in the rocks or fractures are filled all the time with water. It is not necessary. If connectivity is there, then only these will be filled, otherwise they will remain void. So, that may be in the soils or if soils or below the soils you will have the geologic strata, means different types of rocks are there. So, that water we call as groundwater. And sometimes in literature you will also find that a due term is also used or a different term is used, which is called subsurface water, because the water which is available in subsurface conditions. So, that is why in some countries more subsurface water is used. So, this basically distinguishes it from surface water very easily, and which is found in again large bodies like oceans, lakes, the surface water, and which flows over land in stream. So, again the surface water and groundwater are there. Now, both type of waters, that is surface water and subsurface water, are related through the hydrologic cycle. So, they are intrinsic part of the hydrologic cycle. And as we know, we have already discussed in previous discussions that the hydrologic cycle is a continuous circulation of the water in the earth atmospheric system. And that also we discussed that the water all the time remain in this system only. So, water may be underground, water may be on the surface, or water may be in the atmosphere, but there is all the time, this is the hydrologic cycle is a continuous dynamic system. Surface water is vitally important to our everyday life, as we know that we need water, and the water, if it is available through surface or subsurface, it is very important. But there are many places where only surface water is exploited. There are hardly possibilities of getting subsurface water. So, as we know that the surface water which can be supplied for drinking purposes and public uses, also for irrigation uses, and for by other industries like thermoelectric power, industries to cool electricity generating equipment, or even I mentioned about the thermal power plants which burn the coal, they create the steam. So, that for steam generation again you need the water. So, lot of water is required. Now, as also discussed in earlier discussions, that in India we mostly depend on groundwater for the remaining part of the year when we do not have the rain. So, groundwater in our country is exploited most, but depending on geologic conditions in different parts the situation is different. So, as we know that whether it is a surface water or subsurface water, the main source of water on the surface or under or in subsurface condition is the precipitation. Precipitation which includes all the rain and snow, hails and everything. And the precipitation infiltrates, as we know, below the ground surface into the soil zone first, and later on it may as you can see here, the infiltration occurs in the soil part, and then that might move further, percolate down, and can become a saturated part of in subsurface condition. So, below that or that part is be called groundwater, and the margin between these two is called between unsaturated and saturated we call as water table. So, that we will also discuss also in little later. There are two terms which are used sometimes interchangeably, but they have got completely different meanings. So, let me make here these two terms very clear. One is we are saying water table, and sometimes people call as water level. So, these are two terms sometimes people use as I have mentioned interchangeably, but it is not correct to use like that. Water table means that when measurements are done through the say open well or some other means about to know the what is the level of water in subsurface condition. So, for that purpose we lower a tape and measure the depth, that at that time it is water level in a well, but there may be undulations in the topography. So, if we want to give a reference surface, not a topographic surface, but reference surface like above mean sea level, then that time it is called water table. So, when we say shallow water table, that means it is quite close to quite close to the surface, ground surface. And when we say deep ground water table, that means it is very deep to the from the surface, but might be very close to above mean sea level. Whereas water level, as I have just mentioned, that it is measured from the topographic surface. So, there are two different ways of referencing or naming these two things. One is from topographic surface, that is called water level, and one is from with reference to mean sea level, that is called water table. So, this distinction must be remembered in our discussion. So, as we know that the zone of saturation occurs when all the interstices are filled with water, and then it becomes a completely saturated part, and there is also a zone of aeration. Aeration means that when the air is there, when it is not fully occupied by the water, but partly it is occupied water and partly by air, then that part is called unsaturated zone or zone of aeration. So, below zone of aeration and above the zone of saturation, that line or that surface is called water table. So, in a section definitely we will see as a line, but in fact it is a surface in subsurface condition, underground condition. There might be in some situations there might be an intermediate zone. So, intermediate zone, if we would like to define, that is that part of unsaturated zone below the root zone and the above the capillary fringe, and as shown also here that this is the intermediate zone which is shown. So, this is below the root zone, roots are shown also, and above this capillary fringes. So, this part is also called intermediate zone. In all setups, it is not necessary that we may have intermediate zone. One, season to season also it depends. In monsoon season, when the soils from the top are completely saturated, the intermediate zone may not be there, or if it is there, it might be very thin. But in summer time, in Indian conditions, then intermediate zone in some places may be quite thick in that sense. So, this is a changing scenario in that sense. So, as we know that groundwater, it is assumed that groundwater continues to descend until at some depth it merges to a zone of hard rock. That means that a part of in subsurface condition you may find a zone of saturation, a complete saturation zone, but it is not necessary that below the saturation zone you would have all the time saturation zone. So, it does not continue all the time. So, that means it will end somewhere. When it will end, when we find completely hard rocks without fractures, without weathering and without much pore spaces. So, there water cannot enter. So, that part, so above that part you are having the availability of water, otherwise below that you are having hard rocks. So, that is why it is said in many locations or many situations that it is not good to go deep for deeper wells, because after certain depth you may not find water, because you are encountering then hard rock, and hard rock without weathering, without fractures or without any voids will not have the water. So, water is not available as you go deeper and deeper. It is not true. Some people are having misconception. So, this has to be removed completely, because ultimately even below Indo-Gangetic plain, maybe after certain kilometers you would find hard rocks. So, there is a basement rock all the time, and basement rocks may not contain water, may not have opportunity to store the water. So, water contained, as you know, in the pores of such rocks, but the pores are not connected and will not migrate. So, sometimes water may be there, but if permeability is very poor, if they are not connected each other, then it is no use of, you cannot withdraw the water, you cannot exploit that water. And also we know that the main source of replacement or replenishing of groundwater is precipitation. So, the recharge which occurs during rain is the most important to replenish the groundwater. If that does not occur or occurs less, then we are having problem of groundwater recharge. So, this is again in some parts of the country like in India, sometimes we get normal rains, so recharge occurs, sometimes we do not get normal rains, a drought period. And then what happens, then less precipitation, less groundwater recharge, and our water table goes deeper and deeper, only up to certain depth, and then you do not get the water. So, the water scarcity problems becomes very large. So, in general what we think that the recharge occurs only during the rainy season in tropical climatic conditions or during winter in temperate climate conditions. Basically, whenever there is a rain, we are having more chances of recharge. However, if there are surface water bodies which are having sufficient water, then that water will also recharge the groundwater regime. So, that is why for recharging groundwater, some surface water bodies are also required. If we completely start depending on the rainfall, then only we are having that period available. But otherwise, if it is water bodies are there, surface water bodies, then recharge can occur even for round the year also. And so, typically 10 to 20% of the precipitation that falls to the earth enters water bearing strata, and which are known as aquifers. So, this term we are introducing here, that is the aquifers which are water bearing strata or water bearing rocks or layers, if you in simple terms you can think that part of the earth which is saturated with water, and these are the rocks, not the soils, then we call aquifers. There are different types of aquifers. So, a body of porous rock or sediment saturated with groundwater. Also, groundwater is constantly in motion. Why? Because it is not all the time a flat surface. There may be some inclinations. So, where the discharge is occurring, the surrounding water will move towards the discharge, and therefore, all the time water is moving. Though this transmissivity means movement of water from one place to another in subsurface condition may vary. Sometimes it takes days to move for 1 meter, and sometimes it may move in just few hours. So, it depends on the subsurface conditions or subsurface geologic conditions. So, like we know that the surface water moves compared to surface water, groundwater moves relatively very slowly, and its actual rate depend on the, as I have said, transmissivity and storage capacity of the aquifer. So, these things have to satisfy, then we may have little faster transmissivity in case of groundwater movement. But generally in hard rock terrain, it moves quite slowly. Quite slowly means, as I have said, maybe 1 meter in 24 hours or even less, depending on the permeability and connectivity in the rocks. So, natural outflows of groundwater, as we know, that take place through springs. Springs are those places because of topographic arrangement, the water table is cut by the topography. either naturally or human made. Like many times if we travel in the Himalayan terrain, we find that along roads we are getting springs, because along roads the slopes have been cut for road construction. So that the wedge which has been removed of the slope where the water table has been cut, and therefore you observe lot of times we observed springs in such situation along the road. And river beds also, so they are recharging there also, or water is available, and below even the lakes there might be springs because of topographic arrangement. So when the groundwater pressure is higher than the atmospheric pressure in the vicinity of ground surface, then spring occurs in even a flat terrain. It is not always a cut along the road. So very often a bias exists in favor of development of surface water, over exploitation of groundwater to meet water supplies in spite of many inherent disadvantages of groundwater over surface water. Because you can see that development in surface conditions, and some types of decisions always taken so that the things can be seen on surface, and therefore there is a bias which exists. And we know that groundwater is available to a greater or lesser extent in most part at fairly accessible depth. Most part, this reference to the Indian conditions, and can easily be tapped, whereas sites suitable for impounding surface water are limited. That means that surface water cannot be everywhere impounded, and that means reservoirs, small or large, cannot be made every places. Whereas groundwater in subsurface condition, the water can be stored, and of course there will not be any direct manifestation of availability of subsurface water or groundwater. But somehow people feel that storing on surface is much easier, but from long term point of view it is not good, because it occupies a fertile land sometimes of the surface, and then other problems will also come, like it can be polluted very easily. Evaporation is also very high with surface water, and the availability becomes in dry seasons or summer months, the evaporation is much more, and this water, the storage on surface may become completely empty. So then we completely start depending on the groundwater. So groundwater sources are more reliable than from the surface sources, and especially, as I have mentioned, periods of droughts or dry seasons or dry months. And groundwater supplies are generally free from suspended and organic impurities. I have already indicated that there are a lot of chances of getting impurities in surface water, not in subsurface water. And because subsurface water is having when there is a recharge to the groundwater, then this natural infiltration or natural filtration occurs, and that filters the small particles, suspended particles from the rainwater, and therefore the subsurface water in that sense is free from suspended load, whereas surface water may have all these kinds of problems. Also, groundwater has a more consistent physical and chemical qualities, unlike the surface water. Physical, here the temperature is also constant in terms of physical characteristics of groundwater. Most of the time it is having almost same temperature. While alternate sites are available in event of wells going sick in case of groundwater, whereas finding alternate sites for reservoir are very limited, because a reservoir there will be siltation. How fast depends on the terrain conditions, and in the catchment area, what kind of erosion is happening, what kind of weathering is happening. So sometimes it is very, first of all it occupies large part of land, and secondly because of high evaporation and because of suspended sediments, load, solid, organic matter, and also the siltation problem. Siltation problem with surface water is another big problem. A life of a surface water body may be sometime 30 years, 40 years, 50 years. and then either desiltation has to be done, which is again very expensive option, or that site has to be abundant. So, in that way it is not whereas in groundwater developed wells where it is required, investment required is much smaller, land part is required also very much, and construction and distribution system can be developed very easily with groundwater. So, things are going in favor of definitely in groundwater. Installation of groundwater source points can be completed within days or weeks, only you have to dig a well, unlike surface water projects which requires a long gestation period. Sometimes multi-purpose reservoirs in recent years in India which have been constructed have taken sometimes even 30 years to complete these. So, the benefits are not coming immediately, whereas with subsurface water or groundwater these benefits can get immediately within weeks also. So, groundwater wells do not need much more space, as I have already said, unlike the surface structures, dam and other thing. Another very important point is generally the groundwater wells are under individual controls, and therefore, the utilization and other maintenance and other parts becomes also very easy. Whereas, generally surface water bodies are in public domain, and their maintenance, keeping pollution under control, keeping other things away from the reservoirs becomes very difficult. So, the areas which have been in recent years brought under surface water irrigation development program created water logging. In earlier lectures, I have given the example of some parts of Punjab and Haryana, where because of intense irrigation, water logging problem, salinization of soil have become a problem, and that part of the country have become almost kind of a desert, because the salt are on the surface, few inches thick salts have come up on the surface, and therefore, you can't grow any crop there. So, it is not good. So, solutions have been done to find out some drainage, so flush out the salt, remove the salt and that kind of thing, but these are the very expensive options. So, instead of using surface water to as far as possible, try to always go for groundwater. Shallow water table condition will increase flood hazards. That is the only negative point. If we recharge too much, then there are chances, because the saturation part will become very shallow from the surface point of view. Cooling and air conditioning in past 20 years made heavy demands on groundwater, especially for industries, and because of this because of the characteristics of surface water which does not have the uniform temperature, whereas of course, your groundwater provides the uniform temperature. Other is it is usually low in dissolved solid, which I have already discussed, and when harnessed it is available in a large quantity by gravity flow with surface water and serve multi-purpose like flood control, power generation, navigation, etc. So, these are the some advantages with surface water, that these of course, definitely a reservoir or a barrage definitely helps to control the flood, can save the cities, and can divert through barrages, we can divert the water for time being, and that becomes very useful. Sometimes these large water bodies, especially rivers and other things, are also being used for navigation purposes and other things. And another important thing, because it say all waters are linked, all are part of hydrologic cycle, water cycle, and therefore, in order to recharge the groundwater regime, we need the surface water. So, it is not the surface water is our enemy, surface water is equally important, but from a storage point of view, for to make long term available water, to make water available for a long term or round the year, then the best solution is groundwater. So, if we recharge the groundwater regime in an area during monsoon time or by through some surface structures, then the our groundwater will be available sufficiently for the round the year. So, that is the best solution. So, groundwater development requires of course energy, and even to withdraw water from groundwater well, you require the energy. So, pumping is required, and only in exceptional cases you may have artesian conditions where are free flow kind of or flowing wells are there or some springs are there. Otherwise, in order to exploit the water, groundwater, you need the energy. So, this is one thing which goes against groundwater. It is, as I have already indicated, that it is in all the places we cannot store water in subsurface conditions. So, there is no other choice only to go with surface water. So, because of the underneath rocks are completely impervious or maybe the water may be saline, and therefore, the groundwater cannot be exploited there. So, we completely depend on the surface water, but the problem will come in dry season or in summer time. However, in recent years a phenomenal increase in the use of groundwater for domestic irrigation, municipal and industrial supplies has resulted in many areas in extraction of groundwater far in excess of net natural recharge. So, it is a simple budgeting. Budgeting means that if we keep recharging our groundwater regime in all opportunities whenever there are rains, then if our budget remain a groundwater budget remains surplus, then we can exploit the water for all purposes round the year. But if this budget becomes negative budget or deficient budget, then we will not have water in subsurface condition or we have to go deeper, but deeper has got the limit. So, that is one of the problems which have been observed in recent years. Our requirements have increased very significantly, whereas accordingly proportionately our recharge has not been done, and therefore, we are having, I would say, deficit budget in case of groundwater. So, the solution is to increase the recharge by all means whatever the possible as per the local geologic conditions. So, serious local water shortages have been developed under these conditions because of over-exploitation of groundwater and with adverse effects as persistent water level declining. Many states in India have observed this thing, but in recent years at only one state which I understand where the water table has risen, means it has become little shallower, that is the Gujarat, where large scale groundwater structures, recharge structures have been constructed. And of course, if such measures are taken on an extensive scale, on a large scale, then definitely water table will improve and the availability of water through groundwater becomes much easier. So, the excess of groundwater due to surface water irrigation can produce water logging and serious drainage seepage problems also there. So, basically what is basically required for all areas, a balance has to be struck between surface water and subsurface water and between recharge and exploitation. And if area wise, basin wise, catchment wise, if such balance is struck, then there will not be much problem. So, this problem of excess, twin problems of excess withdrawal and surplus require that effective steps to be taken for management of groundwater resources by artificial recharge to aquifers whenever we are having surplus water, and then conjunctive use of groundwater with surface water in later case. So, whenever there is opportunity, as I have been mentioning repeatedly, the recharge of groundwater regime should be done through even artificial methods and even impoundment of water on surface. And the best solution which I feel, and we will be discussing further when we will discuss especially the groundwater recharge, how to do it. The best thing is to delay the surface runoff by some means. If we can delay surface runoff, maybe with small check dams along a stream, that delay will recharge the groundwater regime, and that such structures does not require much energy or much resources and much land. So, that is the one of the best solutions to delay the surface runoff. So, let the water go downward, have a more downward movement than surfacial movement. So, in both the cases excess water and this conjunctive use, the planning can only be done on the basis of knowledge of subsurface and subsurface geohydrological conditions. So, that means the extensive studies or detailed studies are required for all areas to have this kind of. So, let me now summarize what we have discussed in this particular lecture about the different characteristics of surface water and groundwater, and one by one we will be going through. So, like temperature varies with season in case of surface water, and whereas in case of groundwater it is relatively constant. Not exactly all the time you are having the same temperature, but relatively constant and does not change much. Turbidity, of course, in case of groundwater it is very less, but in case of surface water it varies to very high level. Like in monsoon time you do not see a clear water, it is the turbidity is very high. Even in canal systems like in Upper Ganges canal which we see, in season to season the water color in the Upper Ganges canal changes, because it depends on the turbidity, means suspended particles, how much sediment is coming, and sometimes when the concentration of sediments or this the load, sediment load or this sediment load becomes very high and crosses a threshold value, then canal has to be closed. But in case of groundwater, the turbidity either very low or nil. Why low? Because in case of over-exploitation of groundwater, there might be some turbidity in subsurface conditions. So, when water will come on surface, it might have some small particles, suspended particles in it. Of course, color, when turbidity changes, so color changes, and there might be some organic components like algae or maybe sediments component like clays, and they change the color, and sometimes you also get very soft or acidic water, whereas in case of groundwater you due to above all dissolved solids might be there, and in many areas we get in groundwater sometimes we get the hard water which is basically the rich in calcium in many parts. Mineral content, because calcium is easily dissolvable, and if a limestone terrain is there, carbonate terrain is there, then this chance of getting calcium is very high. Varies with this mineral content with surface water, varies with the soil, rainfall, effluents, etc. Whereas in case of groundwater, largely constant mineral content, generally appreciable higher than the surface water from the same area. So, if we compare the surface water or subsurface water of the same area, then there will be some differences in case of mineral content. And divariant, that is iron and magnesium in rich. So, usually none except at the bottom of the lakes or ponds we may get, but usually usually it is present in case of groundwater. Now, excessive carbon dioxide, dissolved oxygen, H2S, NH4, nitrates, silica, mineral, organic, micropollutants, these may be present in both the cases depending on the local conditions, local geology and local effluents if they are available, because after all sometimes the surface water goes to the groundwater. So, it can influence the groundwater also along these things are. So, like if I take the example of silica, which is usually moderate proportions in case of surface water, but in case of groundwater it is level often high, because the water is coming from subsurface rocks, might be directly from rocks, and rocks are very rich sometimes in silica. So, that is why silica. And minerals and organic micropollutants can be present in surface water, but usually these are very less in case of groundwater. And last few more points are living organisms. Of course, chances of getting bacteria and plankton, viruses in surface water is very high, whereas in case of groundwater, iron bacteria frequently found, and chlorinated solvents rarely present in surface water, often they are present in groundwater, and eutrophic nature often increase by high temperatures, but of course in case of groundwater it is a none. So, this brings to the end of our discussion on surface water versus groundwater. Thank you very much.